Hey guys, so we're going to start with some multiplying polynomials here, and we'll start off with just taking a monomial and multiplying times a polynomial. So let's say I had 3x times 7x squared minus 8x plus 3. This is just the distributive property. You guys have done this before, done it probably a few times. So we take this term and we multiply times everything in the parentheses. So this times this, 3 times 7 is going to be 21, and x times x squared is going to be x cubed. And then 3 times negative 8 is going to be negative 24, and x times x is going to be x squared. And 3 times 3 is 9, and then we have that x there. Okay, another one? Okay, this one here, we're multiplying everything by negative 6x squared. So negative 6x squared times 8x squared. Negative 6 times 8 is negative 48. X squared times x squared is x to the 4th. Negative 6 times negative 5 is going to be a positive 30. X squared times x is x cubed. And then negative 6 times 2 is negative 12 times x squared. Negative 12x squared. Okay, so that's how you take a monomial and multiply times a polynomial. So now we're going to look at multiplying binomials, two binomials together. So that would be like 4x plus 2 times 3x minus 1. Okay? Probably the most common method in doing this one would be using what's called FOIL. Okay? The F stands for first, the O stands for outside, the I stands for inside, and the L stands for last. So first, we take the first one here times the first one here. 4 times 3 is 12, and x times x is x squared. Then I take negative 1 times 4x. That's going to be negative 4x. 2 times 3x. That's going to be 6x. And then 2 times the negative 1 is a negative 2. And now we add up our like terms. So my 12x squared stays. Negative 4x plus 6x is going to be plus 2x. And then it's minus 2. Okay, that's the FOIL method. Probably the most common. Okay, if you ask me which one was the most common to doing these, I would think it's that. So let's look at another one. FOIL, first. 3x times x. Okay, 3x squared. Negative 7 times 3x. Negative 21x. 5 times x, the inside terms. And then multiply your last terms, the last terms in each parentheses. So 5 times a negative 7, and 5 times a negative 7 is a negative 35. Okay? So we get 3x squared. Negative 21x plus 5x is a negative 16x minus 35. So I want you guys to try this one. Okay, so my hope is that you will pause that video and you guys will try that, and then we'll see what we got. Okay, we'll see. Okay, let's take a look. So 9x times 4x, 9 times 4 is 36. X times x is going to be x squared. Multiply your outside terms. Negative 3 times 9x is negative 27x. Negative 5 times 4x is negative 20x. And negative 5 times negative 3 is a positive 15. Let's add up our like terms. 36x squared. Negative 27x minus 20x is negative 47x, and then it's plus 15. Okay, so that's the FOIL method. we will spend plenty of time practicing that FOIL method. Okay? And I want to show you, someone will say, well, you should do it by the distributive property. I want to show you that it's the same thing, okay? So let's say I had this. 6x minus 1 times 5x plus 2. So if someone said you did it by the distributive property, it's really the same exact steps. You take this and multiply times both. So 6x times 5x is 30x squared, and then you multiply 6x times 2, but that's multiplying the outside terms. That's O and FOIL. Same thing, man. 12x. Inside terms, negative 1 times 5x is negative 1 times 5x is negative 5x. Then negative 1 times 2 is negative 2. Add up your terms. Okay? Now, I want to show you the area method, or using a table. Okay? Some people call it the area method, some people call it a table. It's the same thing. I'm going to show you get the same answer, okay? So over here I'm going to write 5x plus 2. Okay? And then I'm going to make a table like that. And then over here, okay, I am going to take this one. I don't even think we need that. Here I'm going to put 6x, and then here I'm going to put a negative 1. And it's like you're finding the area of each of these rectangles. So if I multiplied 5x times 6x, I'd get 30x squared. And if I multiplied 6x times 2, I'd get 12x. And if I had negative 1 times 5x, that's negative 5x. And then negative 1 times 2 is negative 2. And then you add up your like terms. 30x squared plus 7x. Well, look at that. Looky there, huh? Same thing. I told you. I told you get the same thing. I told you. Okay? So let me give you guys one with the area method to try. Okay? So let's say you had 4x here. And let's say you had a negative 7 there, and then let's say you had a 3x here, and then a negative 2 there. Pause that video, pause it, try it, see what you get. Okay, see what you get. All right, this times this, 12x squared. This times this, minus 21x. This times this, minus 8x. This times this, plus 14. 12x squared minus 29x plus 14. Okay? So, we've done a monomial times a polynomial, and then we did binomials multiplied together. What if I had this? What if I had that? That's a binomial times a trinomial. And we can't do FOIL because you can only do FOIL with 2 binomials. So, excuse me, we're going to do the distributive property. We're going to take that 4x, all right, here. We're going to take the 4x and we're going to multiply here and here and here. And then we're going to come over here and take this negative 5 and multiply times there and there and there. And then you combine your like terms. So 4x times 3x squared. 4 times 3 is 12. X times x squared is x cubed. 4 times negative 11 is negative 44. And x times x is x squared. And then 4x times 2 is going to be 8x. Negative 5 times 3x squared is negative 15x squared. And then negative 5 times 11x is going to be 55x. And then negative 5 times 2 is a negative 10. So let's add up our like terms, guys. 12x cubed. That's going to be minus 59. X squared. Plus that and that. 55 and 8, I think, is 63. Minus 10. All it is the distributive property. Okay, that's it. Nothing special there. So I want you to try this one. Give it a shot, guys. Give it a shot. Pause the video. Multiply. Multiply. Okay. So x times x squared is going to be x cubed. X times negative 3x, negative 3x squared. X times negative 2 is negative 2x. 5 times x squared is 5x squared. 5 times negative 3x, negative 15x. 5 times negative 2, negative 10. All right? X cubed plus 2x squared minus 17x minus 10. How many got it? Raise your hands. Excellent. Look at that. I think I see everybody's hands up. That's awesome. Awesome. Really, really cool. Okay, really, really cool. So the next thing I'm going to go over is really the same thing, guys. They call these things special. It's really not that special. Special is supposed to be out of the ordinary, but they're going to say special, let's see, special what? Products of polynomials. So special products. Product mean we multiply. Okay, let's say I had this x plus 6 times x plus 6. I could write that as x plus 6 squared. Okay, now x plus 6 squared is not equal to x squared plus 36. You can't just square that and square that. You can't. You can't do it. Don't do it. Okay, don't even think about it. You look at it, don't even think about it. Just walk away. You get that urge, just walk away. All right? Because it's not going to be right. Okay, it's not going to be right. I'm really going. I'm going to go plant a tree tomorrow because we are killing this paper, killing it. So let's go over here. X plus 6 squared. What does it mean when you square something? It means you multiply it times itself. So you do x plus 6 times x plus 6. And then just FOIL it out. That's it. That's all there is to it. It's not that special. X times x is x squared. 6 times x is 6x. 6 times x is 6x. And then 6 times 6 is 36. Combine your like terms. X squared plus 12x plus 36. That's it. So my advice to you, my advice would be to take this and write it as the product of two binomials. That's what I would tell you to do. And it's just easy, man. You don't make it any harder. There's a shortcut I'm going to show you in a few minutes, but I think this is the best way to go. I'm all for shortcuts if it makes sense. I don't think it makes sense in this situation. I don't. Okay? So let's try this one. 3x plus 1 squared. So you guys are going to do that, okay? And when you do it, I want you to do it this way. 3x plus 1 and 3x plus 1. Go. Okay, so hopefully you paused the video and you're back. Okay, you could have taken a break. You might have went and got something to drink. You know, maybe some Powerade or something. Keep you going here. Energy drink. 3x times 3x. What's 3x times 3x? 9x squared. 3x times 1. 3x. 3x times 1. 3x. 1 times 1 is 1. So you get 9x squared plus 6x plus 1. So I'm going to show you the shortcut, but don't feel like you have to use it because, I don't know, I don't think it's that big a deal. So they give you a formula, and the formula looks like this. You take the first term and square it. You do this times this. A times B is AB. Double it. 2AB. And then take that and square it. Okay, that's the formula they show you in the book. Okay, now I'll do this one with a shortcut. 3x plus 1 squared. Take the first term and square it. 3x times 3x is 9x squared. This times this. 1 times 3x is 3x. You have to double that. What's 3x doubled? What's 3x and 3x? Yep. 6x. Plus 1. Because 1 squared is 1. Okay, so did you save that much time? Is it really worth, you know, taking the shortcut? I don't know. I'd say probably not. Probably not. If you want to try the shortcut, here. Go ahead. Go ahead. You want the easy way out? Don't you know, parents always say that? Don't take the easy way out, buddy. Well, sometimes the shortcut helps, and it's worthwhile. I don't know that it's worthwhile here. You guys can decide. If you want to do shortcut, go for it. It's up to you. Try this, at least try this one by the shortcut. Pause the video, try it by the shortcut. See if you can get it. Okay, you're back. First term and square it. 25x squared. This times this. 2 times 5x is 10x. Double it. 20x. And then take this and square it. Plus 4. Okay, we are almost done with this section. 2 more things to look at. One is this. When you have one written this way, where the terms are the same but the sign is opposite. Let's watch what happens. Something interesting happens. X times x is x squared. Negative 4 times x is negative 4x. 4 times x is 4x. And then 4 times a negative 4 is a negative 16. So what do I get? What do I get here? X squared. What happens with my negative 4x and my 4x? Yeah, they cancel. So if they cancel, you're left with x squared minus 16, and there's your answer. Okay, so when all of your terms are the same and the only difference is the signs are opposite, your middle term is going to cancel out. Okay, we're going to learn that factoring pattern. The factoring pattern is called the difference of 2 squares. We're going to learn that shortly, very shortly. Okay, so let me give you guys one to try. Okay, all the terms are the same. The only difference is that middle sign there is different. Okay, so give that a shot. Okay, so let's look. 5x times 5x. That's going to be 25x squared. Negative 3 times 5x is negative 15x. 3 times 5x is positive 15x. Guess what they do? Cancel out. 3 times negative 3 is negative 9. So I get 25x squared minus 9. Ding, ding, ding. Ding, ding, ding. Okay, last piece. Last piece. The science teachers will be happy when we do this. Okay, they will. Okay, and it's called Punnett Square. Some of you guys are like, oh, I already did that. Okay. So this has to do with genetics. Okay, and the example I'm going to use is for a border collie. Okay, border collie is a kind of dog, and each parent has 2 color genes. Okay, capital B stands for black. Okay, and the small r is for like a red patch. This is like a black patch, and that's a red patch. And the black patch is dominant, which means that's why it's a capital B. Okay, so if you had 2 of these border collies, okay, and you were going to cross them, okay, and then you're going to look at what's the possibility, what's the probability of getting a red dog from 2 parents who are black and white, okay, black patches. So this is how you write it, okay, the parents, okay, so black is the dominant gene, but they still have that red gene in them, okay, and then here this one's black and they got that red gene in them, okay. So let's look. Capital B times capital B is going to be BB, both capital. B times R is going to be capital B small r. Again, capital B small r. And then here, R times R is going to be little r, little r. Well, if you know anything about genetics, which I don't know a whole lot about, but I know if there's a capital B, it overrides it. So this would be black, this would be black, this would be black, and this would be red. So if someone said, if you took these 2 parents and they had an offspring, okay, what's the probability that they get a dog with red patches? Well, 4 things can happen, and only one of those is red. So there'd be a 1 in 4 chance that the kids got red patches. Okay, you know, that's if the parents were the ones that were, you know,